In this tutorial we are going to fly the DC Designs Concorde in Microsoft Flight Simulator 2020. We are going to do our flight planning from Paris to Cairo in a tool called Little Navmap and talk about the tank and trim systems of the Concorde. Based on these calculations, we're going to load the needed amount of fuel and our desired amount of passengers and cargo in the simulator. After an overview of the important sections of the flight deck, programmed as individual cameras, we go cold and dark and start up Concorde with an essential checklist. We then fly from Paris to Cairo with explanations into all the important phases of the flight, concentrating on the supersonic parts and special features of Concorde. In between we have a look outside. Concorde is a beautiful plane and the Mach cone of silence is always stunning. Approach and landing are not a focus of this tutorial. I usually do my flight planning in a tool called Little Navmap. Absolutely brilliant tool. Connects with the flight simulator, shows you position of your plane, all the other data. I programmed a very simple flight route for today from Paris Charles de Gaulle to Cairo. You don't want to have complicated routes with Concorde, especially not in high speeds. If you do too heavy turns, and I mean more than 5 degrees, you'll disturb the supersonic flight envelope and lose energy. So we are going to avoid that. Departure in Paris is 26 right, straight out. We're not going to follow procedures with Concorde after all. And in Cairo, we're going to fly more or less straight in from Cairo VOR, port side VOR, to the ILS approach with an approach fix of 2,000 feet into 2-3 left. In order that the tool can create the amount of fuel that you're going to use, very important of course, you have to create a performance file on the fuel report. You find them for common types on the internet, not really from Concorde, so I built my own. I measured it. You can do that with the tool and collect the information and build your own performance tool, or you just use my values if ever you want to do that. With these numbers, the calculated amount of fuel that we're going to use is about 120,000 pounds. Concorde is in kilograms. It's a European plane after all, but the interface in Microsoft Flight Simulator is in gallons or pounds. We're not going to use gallons, so we're going to load 122,000 pounds of fuel for that flight. Another speciality is we have different tanks, so we need to decide where we are going to load that fuel to get a reasonable center of gravity. And for this flight, I prepared screenshots of load sheets in Microsoft Flight Simulator that you could use. So you have a stable configuration. This is the load sheet for our flight in Microsoft Flight Simulator as we calculated before. We're going to need about 120,000 pounds of fuel. That's how that is distributed amongst the different tanks. So we have the amount that we need, but we still reach the CG that we need of 54 for departure. As we are quite light on fuel, we're not going to use that much fuel, 60% about. I cheated a little bit, put a lot more baggage in the back to be able to have a heavier plane while still being in a reasonable range for the center of gravity. That brings us for the weights to about 210 knots for takeoff, V1. Extremely fast for a commercial airliner. On approach, about 220 knots, and for landing, we expect to be about 120 tons to about 170 knots to the ILS in Cairo. Next is a quick tour to the flight deck, the cameras I use. My number one is the standard camera. I have the autopilot in view. Important engine instruments, my flight instruments, navigation down here, gear position. If I need a closer look, I go down here. That's my number 2. So I have a better look at the autopilot, the engine instruments and everything else. Number 3, my FMC in the middle, outside temperature, speed, altitude on the left, our temperature of our fuselage on the right. Behind is the parking brake, throttle levers, and the afterburner switches if you turn them on and you go to full power with your stick. You'll have afterburners. If you turn them off, you go to full power. It's just the engine, standard engine. My camera 5 is the engineer's panel, super important. Fuel system in the middle, tank system. Right side is the engine, panel. Engine instruments and your basic flight data, speed, altitude. Number 6, overhead panel, standard. You have your different stabilizers down here, your landing lights, taxi lights, your internal lighting with the knobs up here, taxi light, fasten seatbelt signs, and outside lights up here. Number 7, that view I programmed is useful to start the engines. You start them here, and you can control the spooling up on the left side of the engineer's panel. That were the standard cockpit cameras I'm going to use during this tutorial. I have even programmed a window so I can look outside, and I can also check on my passengers. Concorde fuel system is also unique. As you see here on the engineer's panel, on the left side are the engine instruments and configuration switches. On the right side we have our electric panel, and in the middle is the tank system and trim switches. In Concorde you have basically 3 systems. The red systems are feeding directly into their respective engines. The blue system is where the main fuel is located on the left side and on the right side. And you have 2 particular tanks in that system, 5A and 7A, which are located here on the top of the panel, which are actually located at the back and on the outside of the wings. And these tanks will have to be emptied during supersonic flight. Then we have the green system, which is the trim transfer system. On the back, tank 11, and in front, tank 10 and 9. For departure, the center of gravity, which is indicated here in the middle, needs to be at 54%, which it is right now. But in our supersonic flight envelope, we need to pump fuel back. We cannot trim Concorde with trim surfaces like we would do in every other aircraft. The drag is just too high, the speeds are too high. So we have to trim Concorde with the fuel. And we have to pump fuel from the front to the back to get the center of gravity also to the back of the plane at 59%. For that, we're going to open valves on these tank and the pumps on these tanks so the fuel can flow to the back. For descent, we have to do vice versa and put fuel to the front again to again get to 54%. So we're going to open pumps down here and valves up here. It is also possible to pump tank fuel into the main tank system if you get low on fuel. But usually these green tanks are just for trimming. Very unique system in Concorde. So we're going to have to do a lot of pumping and trimming and open valves during flight. We are cold and dark at gate K76 in Paris-Charles de Gaulle. We're going to do an essential checklist to start up the plane, starting with the engineer's panel. First, on the right side, we have to turn on our electrical system, ground circuit switch, both batteries, the APU, guarded switch, and the circuits for the generators. Now that the indications are alive, we can check our fuel correctly and our weight. We're going to turn on the engine valves, fuel valves. And the cross feeds. Then the secondary air doors we do to auto, so we don't have to take care of them later. And also auto for the engine control schedule. Next, we have to move a little bit to the left. Fuel heaters, also auto. And for the last, a little bit up. And the engine bleeds. One is already on because of the APU. Now we have turned on the rest. That was it for the engineer's panel. We continue with the overhead. First, we're going to turn on the nav lights to indicate that we're powering up. Seatbelt signs, no smoking signs, then the two anti-stall systems and all stabilizers. Next up, autopilot. In this view, we check our autopilot settings. We switch to INS, that means after we turn the autopilot on and go to INS mode, we're going to follow our very simple flight plan that we planned before. That also means that the right side is active and is going to be programmed automatically by the flight plan. If we approach our destination, we go back to RAD. That means the left side is going to come active, and we can choose our own ILS settings for the approach, which we're going to initiate by glide, by clicking on glide slope, or even land to auto land. But we're going to fly manually. But for the moment, we go back to INS, so we're going to follow our flight plan. Next up, speed, initial speed. We're going to accelerate to 250 knots below 10,000 feet, standard restrictions. And we're gonna go to 10,000 feet. You have to click, so you are on 10,000 feet. And the runway heading. (264) just in case we need it. Next step, transponder. And finally, our QNH set correctly is a bit difficult to see, but the airport altitude is correct. Next up, FMC. In our very archaic flight management computer, we have to program GPS position, reference airport, gate. In the flight plan, we have to choose our departure runway 26 right with no SID. Destination Heka we leave empty. We have the waypoints for the RNAV programmed in our Microsoft flight plan. Under data, flight number, cost index, flight level check, and the block fuel check. Performance, we're gonna read our V1 speeds, should be about 210 knots. V2, about 215. Transition altitude, and on the approach phase, we're gonna set our QNH, temperature, wind, transition altitude, decision height for our arrival. RadNav, we're going to set the ILS frequency of Heka runway 23 left 108.7 with a CRS for the ILS runway of 224. And with that last configuration, we can start our engines. Before we start the engines, we have to turn on the beacon to indicate that we are powering up our engines. And then we are going to start engines in a particular order: 3, 2, 1, and 4. You can monitor the progress of the starting up here or in the middle console. Now that all engines are running, we need to set the limiter for engine number 4. Then turn on our taxi lights. Release the parking brake. And we're ready to taxi to runway 26 right. We're at the holding point, runway 26 right. Quick departure briefing. On the runway, we're going to go to afterburners and full power afterburners for 30 seconds. Then we have to turn them off because of noise. 250 knots to 10,000 feet. Autopilot engage with INS mode, so we're going to follow the flight path. And altitude acquire to 10,000 feet. Auto throttle with speed acquire 250 knots. At 10,000, we accelerate to 350 knots by climbing to 24,000 feet. And there we start our supersonic flight and trim. We're going to be back at this moment. We have to turn on the landing lights, arm the transponder, and our flight directors to be ready for departure. We are ready for departure, runway 26 right at Paris Charles de Gaulle. Autopilot is programmed, visor is down, lights are set. We're gonna pre-engage our afterburners so we can use them if we go to full power. Parking brake release. We start the timer to have 30 seconds that we need to turn off again because of noise. Brakes, spooling up. Stable, full power set. Afterburners on, brakes release. Speed rising both sides. Hundred knots. V1, rotate. Positive climb, gear up. Seek 250. Nose up. Autopilot on, INS mode, altitude acquire, afterburners off, auto throttle on, speed acquired, 250. We're going to climb to 10,000 feet, then accelerate 340 knots, climb to 240 flight level, and then we'll be back to start our supersonic flight. Lights off. We are at flight level 240, 340 knots. We have to start our trim. We need to trim the plane back so we can accelerate and climb. We're going to turn on the afterburners, go to max power and engage the autopilot mode max climb, which should bring us to about 45,000 feet at Mach 1.7, where we're going to turn off the afterburners because at this altitude and speed they don't contribute anymore and just use an enormous amount of fuel. So, for the trim process to start, we go to our engineers panel and we have to start the trimming. Now you see we have to pump fuel from the left system in the front of the plane to the back, to tank number 11. And the CG needs to rise to 59 degrees. I'm gonna open up the inlet valves of tank 11, turn on the pumps, especially on tank 9, because this one is the most in front. so the CG is going to come back to the plane, which helps our ascent. Next we have to turn on the afterburners, or potentially turn them on if we go to full power. Right next. Altitude new 45,000 feet. Alt acquire for the moment. We go to max climb afterwards. Auto throttle off. Full power set. Afterburners are now in use. We're gonna leave full power for the rest of the flight, very unusual for a plane. We're just gonna turn off the afterburners, as we said, at Mach 1.7. Our speed is rising, almost supersonic. Altitude is coming up. Outside temperature minus 42, that is not a concern. What is going to be a concern for the rest of the flight is our nose temperature. It's going to rise very quickly. Cannot exceed 127 degrees Celsius, or you will hear a very annoying alarm. If we approach that temperature, we have to immediately climb. So the rest of the flight is going to be a little bit of climb, 200 feet. Let it establish, temperature comes up, climb again. So that is supersonic flight in Concorde. Now on max climb, autopilot mode, we're climbing and accelerating. We had to interrupt our pumping process because we're getting too far ahead. That's a constant process. We stopped the pumping and now we can open the valves again, continue transferring fuel to the back. You need to stay inside the yellow markers. Another special tank that we have to take care of soon are tanks 6A and 7A, 5A and 7A, sorry, which are at the top of the panel here, and they need to be emptied after 1.75 Mach. They're on the outside of the wings to aerodynamically adapt the wings to the supersonic flight. So that we're going to do once we go off afterburners in our climb. We're at 45,000 feet, 1.72 Mach. We're going to turn off the afterburners. Until now they were very effective. Now they have much less effectiveness, so we're not going to burn fuel. We're going to continue to climb to 50,000 feet. This time we do Alt acquire to gain altitude a bit faster. If you go to max climb, it's acceleration and climb. If you go to Alt acquire, it's just climbing. We're a bit too fast. Let's check our temperature. 1.82 Mach. We're a bit too fast for that altitude. That means we're a bit too hot. That means we go to Alt acquire to not rise the temperature too fast. And the trimming situation, we have a little bit over trimmed. Doesn't really matter because these emptying the tanks 5A and 7A are going to put the CG back to the front. So we're going to correct that. The pumps are always on for these tanks, so you just have to open these inlet valves and the fuel is going to flow into the main tanks. This for aerodynamically optimize the wings for the supersonic flight envelope. You see, CG is coming back, should be about correct, and if the tanks are emptied, be at 59 where we should be. Otherwise we could always start to empty tank 10. At 50,000 feet, we're going to accelerate to Mach 2.02. We're going to indicate 60,000 feet, and then we're going to a mode that usually works okay, Mach hold. So actually the plane should keep the speed, 2.02 or 4 Mach, and steadily climb automatically to about 60,000 feet before we begin our descent. We are approaching 50,000 feet. Our temperature has come down a little bit, which is good, but now we're losing speed, overshot a little bit, so immediately go to max climb so that it continues accelerating. It's a very delicate process. You're in this Goldilocks zone. If you're in there, the plane is behaving smoothly and no problems. If you have to correct, you have to work a lot. Descend, ascend, etc. I think we are just about in this Goldilocks zone. Bit too slow. That means we're going to accelerate first before we are going to climb again. Trimming situation. Tanks are emptying. Even a bit under 59, so I actually pump the last fuel that we have in our front tanks, and this time also back to tank 11. Turning on pumps, opening valves, closing them. That's the part of the trimming of the Concorde. Very, very unique. We're at 52,000 feet, stabilized finally at about Mach 2.02 with 120 degrees on our nose, so we're good. Trim situation is okay. Took me quite some work to get here, so I'm back in this Goldilocks zone, should be flying from now on. I was too high in the altitude, too slow. I accelerated too fast, so I had to do quite a work to arrive here, but I think we're good now in this situation. We can go to Mach hold and just put in 60,000 feet or something higher, and the plane should automatically start to climb. Temperature close, but okay. Start to climb, should stabilize at about 2.02 or 24. Looks okay. But again, took some work. We are at 57,000 feet. I had to go away from the automatic systems. Mach hold brought me in an oscillation. The autopilot modes do not work well in Supersonic. So I went to alt acquire and I steadily climbed to 300 feet. As soon as the temperature is getting too high or I'm still accelerating, 2.04, I'm gonna climb again. So you have to do it manually. the automatic systems do not really work. We have about covered half the distance to Cairo. Our situation is still good, 2.04. For that particular time, weight, altitude, temperature, 58,000 feet is the correct altitude, and we're still very close to the border, to the limit, but not exceeding it. We are approaching our top of descent, about 160 miles from port side VOR. We've made it to almost 59,000 feet at 2.04, and as usual, very close to the temperature. This was a lot of work climbing 200 feet again. Once I even climbed too fast, lost energy, had to descend 2,000 feet and kind of start again. That's Concorde. At our top of descent, we're going to descend to 36,000 feet, reduce our speed again to 350 knots, and we also have to trim the plane to the front again. Trimming is good, 59%. Fuel situation on the right is not too good. As soon as these low level come on, I'm going to start pumping fuel from the remaining trim tanks into the right side. Should be okay. Approaching our top of descent, it's very difficult with Concorde to lose the energy, so I prefer to descend a little bit earlier and drag myself in than to arrive too high. So first of all, I'm going to go to auto throttle. We want to lose some speed, altitude acquire, speed acquire, and engines are spooling back, and we go to 36,000 feet. You have to put the engine rating in climb again, then we put into cruise once we reached our 50,000 feet, and we also have to start the trimming from the back where there's a lot of fuel to the front. So I'm going to turn on these pumps, tank 11, and open up the inlet valves for tank 9. CG should start to go to the front of the plane for landing, for approach, to, again, 54% center of gravity. We're approaching the normal commercial airliner envelope. We're about to go subsonic, 1.05 Mach at 40,000 feet. That is where commercial airliners usually operate. Our trim situation, still trimming to the front of the airplane. I soon have to stop the trimming because I have not enough fuel on the right side. That's what I'm going to do now. I'm going to stop the pumps at tank 11. Close the inlet valves, open another route into that right system. I'm going to use the inlet valve for tank 7, and if I turn the pumps on now, it's going to pump fuel to the right side. It's also going to put the CG a little bit to the front, but the situation here is more important. You see fuel is coming up. I'm going to fill these tanks a little bit and then continue pumping to the back. about subsonic, approaching 36,000 feet. We're going to descend further to flight level 240, reduce speed to 325 knots, then descend to 10,000 feet, 250 knots, and go into our approach for Hecka. 2-3 left, the ILS is programmed. What we still need to check is our approach speed in the FMC under performance. We are at 24,000 feet, 325 knots, standard speed and altitude for a commercial airliner. Our trim situation is good, 54%, that's okay. We have enough fuel in both tanks, on both sides, engines 1 through 3 and 4. We still have to check our approach speed. The approach is 220 knots. Below 10,000 feet, and our weight in the moment, can't see it too good, is 130 tons, and according to the manual that gives us about a landing speed of 175 knots. Reduce speed to 75, approaching 10,000. We're going to reduce to 250, and again descend to 10,000 feet. Descending to 2,200. Nose is already down. We have to do some housework, seatbelt signs on, etc. Landing lights on. Taxi lights later, landing lights on. And as soon as we get closer, we're gonna change to RAD, and we will have the ILS pre-programmed, so that would indicate the ILS down here with the DME, like in normal airplanes. We are approaching our final turn into the ILS of runway 23 left in Cairo. We're going to reduce speed to 175, our approach by our landing speed, and then we're going to turn off the autopilot and land the plane manually. Nose down, gear down, lights are on. So nose down, gear down, that's going to come up as soon as we turn into the final. Power off. Gear down and reverses. .80 knots, start to brake. reverses off, roll out. We are at the end of this tutorial. I hope you enjoyed it and thanks for your attention.